here we have a lively office, and whenever Matt puts his microphone on, you can hear the racket in the background, so he'll remain muted unless we need him. And any questions? Because we've got a fairly large audience today, it's probably better if you write down questions as we go along, and then we can field them at the end. But please, if there's anything specific, do pipe up. We'll be very happy to try and answer those questions as we go along. But you can imagine when we've got as many as we've got today, the questions can slow things down a little bit. But if there's anything really specific, shout. Lovely. Okay, well, here we go. The art of structural repairs. Why do we call it the art of structural repairs? Well, I think it isn't just a science. Obviously, structural has connotations of codings and all the other bits and pieces, but there's an artfulness to how you do these things. And what we're going to do today is just look at how we can use different types of materials, quite often in unusual circumstances, to get the solutions we want. So that's what we're looking at. That's me. That's the guy who's nattering on at you today. I've been the managing director of Stress UK. Was the original company for over 30 years now. I set it up, and we've run it very successfully since then. And what we incorporate, here we go. It's deciding not to play ball. There we are. So within the group, currently we have three main companies. Stress itself, which carries out structural repairs and refurbishment to almost any type of structure, except bridges, not wholly exclusively. But Goldhawk, who used to be a company owned by Helifix, and the Helifix name will come up a fair bit today. We're an approved installer. Had a company strengthening masonry arches, and this is another CPD for those of you who would be interested, that we could do, and that's anything from vaults under houses right up to network rail and highways structures, but it's specifically strengthening masonry arches. That fits in really nicely with everything that we do in the Stress Group. Due Innovations is our intellectual rights company, and we basically do research and development into improvements in the ground, finding new ways of underpinning, for instance. And that again feeds very well back into Stress Group. And we have various divisions within Stress, some dealing with heritage, as you can see there, heritage engineering. So we tend to deal with listed structures, monuments, old buildings, things like that. Permeation engineering is, again, one of the inventions that we came up with in Geo Innovations, and we can improve the ground by injection work. And then we've got insurance, overall geotechnics, where we do underpinning and things like that. So it's quite an eclectic group of specialist companies. And basically, that's what I was telling you we do. We're members of the Association of Underpinning Contractors, which gives us a level of ground work ability, which is vetted, and gives us surety to our clients, and means we can guarantee the works that we do. But we love unusual, awkward, and high value projects, as you will see as we go along today. Within structural repairs, you've got masonry reinforcement, crack bonding, the cosmetic refurbishment that goes along with that, stone repairs, because obviously dealing with a lot of old listed buildings, we have to do that. What I would say is that working with listed buildings is really quite specialist, and if you haven't done it before, it's easy to fall foul of the local authority conservation officer, and dealing with them is is just, it needs to be done carefully. They're very intelligent people. They know exactly what it is that they require. They know what the rules are and the laws. And if you transgress those, someone goes to jail, or certainly there'll be fines. So we can help steer you through that little lot. So let's crack on, if you pardon the pun. Now, I think everybody can see that that is a pretty standard, quite substantial fracture in a building, and this is a sort of thing that is very common due to subsidence, thermal movement, sometimes certainly impact, as we'll see here. Find out what your cause is, and obviously try and make sure that whatever's causing it is rectified before you then do the structural repair. So in this case, we can see that the cause of the cracking here was some enthusiastic parking, which, funnily enough, I put up for two reasons. One is that it's quite amusing. I can't believe somebody didn't get hurt, which is obviously sad. But we actually get involved in pulling cars out of buildings or vehicles out of buildings more often than you would warrant. And insurers ask us to do that because they know we can safely or make the building safe to be able to pull the car out, because in that particular instance, you don't know what part of the building is now sitting on the car. So just to pull it out, you'd get progressive collapse potentially. So we look at the structure overall, put in whatever necessary temporary works are required, which includes quite often masonry reinforcement to spread loads so that actually you can safely extract the car. So some of the considerations for an effective structural repair: how much disturbance are you going to have to do to this building? Try and keep it to a minimum, because the aesthetics are everything. Because if it looks like it's got an elastoplast on it when you've finished, it's not what you want, is it? If it was your property, you wouldn't want to see all the scars of the repair works. You want to try and match them in, get the color matching going, do as little as is necessary. That's one of the things that's really important here. Find out what type of repair is going to be appropriate, and obviously then record that. If it's a listed building specifically, you have to record everything you do to that property. So we're going to go on and we're going to look at masonry reinforcements. For those of you who don't know or haven't seen this, I'm sure most people will have done. It's a method of installing reinforcement into masonry to do two things: to structurally rebond it, and to distribute stresses in the future. So quite often buildings are subject to differential movement through thermal, through drying outs of clays, swellings of clays, all sorts of bits and pieces like that, or where you've got a building that's been extended and the extension is on a slightly different footing to the main building, then you potentially can get movement between the two. Masonry reinforcement spreads those stresses and usually prevents then reoccurrence of cracking in brickwork. So stages, well, we've got top left, chap with a blue hat. He is actually using something called a Hilti wall chaser. Now, these are a fantastic bit of kit. They were designed for electricians and plumbers to be able to chase into walls, so they can put slots in, run cables, that sort of thing, pipes and that sort of thing. But they're in fact so useful. We use them not only just for domestic houses like this, but in installations and repairs, because you get a very fine and even cut, and they're vacuum recovery. So it's difficult to see, but there's a hose, actually, vacuum hose coming off the bottom of that Hilti wall chaser there, and it will recover something like about 97% of the dust created by the spinning discs. Very accurate cut to the depth you want. Chap at the bottom there, he's feeding masonry reinforcement in. Now that is actually what's called Betinox bar. It's a ribbed stainless steel bar, not twisted heli-fix bar. We use either, same technique, and you place that into the right depth slot, which is all being cleaned out, but we'll go into this a little bit more in the future. And the chap in the top right, in the high-vis, yellow high-vis, is actually the general manager of Helifix himself, John Heseltine, who is pretending to feed cementitious grout into the slot around the bar. But basically, those are the techniques. And then the secret obviously is the pointing afterwards to color match that in so that you don't end up having a scar. But masonry reinforcement, incredibly useful, very versatile method of repairing buildings. So find the best solution for the problem. Know your building. Don't be afraid to use innovation. I think that's one of the things hopefully you'll get today. Be brave. If it's a listed building, engage that conservation officer early. Get them in, talk to them about what it is that you're trying to achieve, and he or she will never tell you how to repair it. What he will do is tell you how you're not going to repair it. And so work out the different schemes, work out the pros and cons, and quite often they'll go, oh yeah, good point. Okay, yeah, happy with that. Can I see some more information on it, etc., etc. And quite often, as you will see coming up, you can get some quite innovative methods across into conservation. So one of the things, we're talking about scarring buildings. Right, here's something very simple. Little semi-detached house, very typical. And there's been settlement of that left-hand flank wall. And the reason was, when we did the site investigation, in fact, those drain pipes never went into a drain. So they've been just draining gently into what is actually on this particular site, mostly sand and gravel. And so that flank wall has settled with time a little bit, and you get that classic crack between two weak points in the building, which are the windows, obviously. That's fine. No problem at all. Easy. If that was brickwork, you just literally go into the bed joints of the brickwork, make good, resin inject the crack, everything fine. If you take a Hilti wall chaser to that rough cast render, no matter how carefully you repair that, it will always be visible in some light or other at some angle of the sun. So you're never going to hide the fact that that has been structurally repaired. So what do? Simple. You go inside. Yes, you're going to disturb the decorations inside, but most house owners will thank you for not advertising the fact that their house has been structurally repaired. So you come inside, you put the helibar into the brickwork, you resin inject the crack, as you can see. This was solid brickwork, but it still works for cavity work in the cavity construction in exactly the same way. So you put your heli beam in, then you tie the two inner and outer leaves together with pins, replaster, redecorate. You'll never know that the crack has been repaired and reinforced. And then what you do when you go outside is don't disturb that rough cast render. So you do some very careful injection work with tiny little 10mm holes along the line of the crack, and then just gently piece in similar sized bits of aggregate, and then sponge it in with some cement paste, with a little bit of SBR in it. And when you paint it, it's not invisible, but actually it's actually quite difficult to see what's there. So this is the art of structural repair. So let's go on to listed buildings. This is or was an old pub in Haddenham, Oxfordshire, and it was bought by a client, it was taken out of use as a pub, bought by a client. He wanted to actually just flip it. But he took on what probably any of you who deal with listed buildings will know is a bit of a nightmare, that you come across stuff that you never knew was there. So this was something that happened there. So all the old barn on the outside was all stripped off, and it exposed this gable end of the main pub with the chimney in it. And as you will see in a minute, you can see the sort of general state of the place. Not great. When you look up that gable wall, you see holes, cracks in the chimney, probably through chimney fires. And everybody realized at the end of the day that that whole end gable was live. So we were brought in by the main contractor, who we do quite a lot of work for, and he said, "Do you think you can save that?" So we looked at it and said, "Yeah, I think we can. It's going to need a fair amount of masonry reinforcement, but I think we understand what's going wrong, and we can save it," which was music to the conservation officers' ears, because they almost refused for it to be taken down and rebuilt, which the main contractor wanted to do. Client didn't want to do it because it's going to cost him an awful lot of money. So to try and save this historic brickwork was a good thing. So off we went with a scheme. When we started looking around, we took plaster off to see what the substrate was, and as you can see there, that gable wall had at some time in its life been rebuilt, because it's in brick. The rest of the building is in stonework. So that was one thing to take into consideration. And then we realized when we got into that corner that in fact there was no tie between the gable wall and the flank wall. So another reason why that whole structure was a bit live. So again, one of the things you've got to do is design a bond in there again. So these sorts of things you find out. You also notice that there's flues in that chimney. You've seen the chimney go up on the outside. So there's bound to be fireplace flues on the inside. Usually with that void there, you get very, very flimsy brickwork, which needs to be stiffened to make that wall work. We'll see that happening in a minute. Whilst we're there, the main contractor said, "Look, I've got another problem. I want to increase the size of that opening." And you can see that opening there with the steel beam over it on the right-hand photo. So we said, yeah, that's absolutely fine. What we'll do is we'll put some masonry reinforcement in. We'll put a masonry beam into that stonework above that existing opening, and you can reduce the amount of propping you need to do significantly. It makes it an awful lot easier. So in fact, it meant that they could put a new spanning steel in much more easily, threw more load onto the corner, so we underpinned the corner, but generally masonry reinforcement makes things much easier to temporarily prop. So as we said, mark everything down the drawing. If it's listed, it's going to have to go off for approval. So you need it recorded. Everybody needs to know, including the client, architect, the conservation officer, your guys on site need to know exactly what's going to happen. So you record it. Normally we'll do it on CAD. This was done just on the architect's drawing, as you can see, annotated. Now, one of the reasons I want to show you this is in plan, you're now looking down top right hand corner there on that gable wall onto the flank wall, and there's that discontinuity. Now, what we see a lot of in design and also when we get to some sites is that the repair that's been put forward is to run the helibar around the inside of the corners. Now, that doesn't really work, because if that flank wall wanted to, sorry, the gable wall wanted to move north up the page, and you had helibar running around the inside, all it would do is pull the helibar out of the wall sideways. So you really want to use the bar, the stainless steel bar, in tension at all times. So you actually drill through and return the bar on the outside. And you can do this almost anywhere. It's a little bit more work, but you get a much more effective repair. So when it comes down to actually the installation, you can see here that we've got stonework, and it's fairly regular stonework, but it's not, the blocks themselves aren't exactly square like brickwork. They've got slight curves to them, blocks are slightly different sizes. So the bed joint isn't straight. If we ran our chaser straight into that bed joint in a straight line, when you do the repointing, those two lines that you see there would be straight and all the other pointing would work around the blocks. So you can't do that. You have to then hand chase those in, a little bit more work around the blocks, and you will get a slightly uneven line. When the helibar's put in, as it is there, repointed, you won't see it. It will completely disappear. If you, however, are going into brickwork, you want to follow the bed joint, and the bed joint normally will be straight. Mind you, when you see some of the modern brickwork that goes up, none of it's straight, which is a pet hate of mine. You never see a perp in a straight line. I don't know how people actually get the brickwork past. Anyway, let's not get onto that. But what I wanted to point out here in that right-hand photo was, if you guys go to site, whether you're familiar with masonry reinforcement or you're not, but you go to site and see it installed, we've seen some horror stories. It's got to be put in right, otherwise there's no point in doing it. So here you can see, you notice that just how clean that cut is. We have removed all the mortar. This mortar's normally pretty weak stuff. So if you're going to use it to spread stresses, it's going to have to bond to something. And if it's friable, it's not going to distribute any stresses through it. So you remove all the pointing over the depth you need it. Something like this, probably you take out around about sort of 20 to 25 mil of mortar. You then vacuum it out. You then wash it out, and then you spray a primer in. So then you put the bar in, and then you go in with the polymer modified grout, cementitious grout, and that will bond beautifully to the brickwork. Surround the bar, it's helical bar, so it binds to it incredibly well. And when that brickwork tries to move, it will distribute those stresses into the bar and prevent further cracking. So that's why it's really important. Left-hand photo is that photograph of the inside whilst we're actually doing some of the works. And this is a mistake here, but I really wanted the guys to put the two bars on the two walls in at different levels, because it looks at the moment like we're going to do exactly what I said not to do, which is run the bar around the corner. Bars on that the right hand flank wall, the stone wall, are actually running straight through to the outside and then returned. The bars on the inside of the brickwork there on that gable wall are there to stiffen that wall over the chimney openings. Right. I'm still trying to get a photograph of that job finished, because in fact it was all repointed by somebody else, and I keep meaning to go back and take a photograph of it, and I will do that. Right, we're going to change tune here a little bit, and we're going to go on to something right up at the top of the listed building chain of structures, and that's Brighton Royal Pavilion. A good deal of you have probably been there and seen it if you've been to Brighton. It's one of those things that you probably should do, really. It's quite an extraordinary, I'm going to call it a monstrosity, really. It's an edifice. It's a wedding cake, really, isn't it? But fascinating place. And we were asked to come in and solve a problem to the Adelaide balcony. Now, the Adelaide balcony, you can see there above those columns, and it runs at first floor level right the way across above the King's apartment, and is accessed from the restaurant if you've ever been there. So it gets a lot of dignitaries on it, and you can have anything up to a couple of hundred people up there. So they realised they had a structural problem, which I'll go into in a minute. We did a lot of work for Brighton and Hove. A little bit of history. So King George IV employed John Nash, a name you will know very well, very famous architect, to design for him a spectacular world-conquering, showy-offy type building um, on the site of an old villa. And John Nash, being innovative, decided that if he used this new product, relatively new product that had come into construction called cast iron, he could increase the size of openings because you're not using timber to span openings, that sort of thing. You can use cast iron columns, keeps everything really slim. And he developed and designed that remarkable structure. He also did this sort of thing in London, which I'm sure you've all been past or into. But it was an engineer called William Strutt back in the late 1800s or 1700s, sorry, who first of all used it in a commercial building called the Flax Mill, and it's up in the Peak District. This is still a museum. You can still go and see this building, and you'll see in a minute why he used it. It gave him much bigger openings, much nicer working environment, much stiffer building altogether. There it is. So that's the Flax Mill. You can go and see that today. Solid floors, jack arches, so brick jack arches that come down into spanning cast iron beams supported with columns. You can see how slender those columns are. So Nash saw this and thought, wow, if I can turn this into a dwelling, into a palace, it's going to impress the king, which it did. However, there's a bit of a problem with cast iron, and that's that it's brittle. I don't know if any of you've probably taken a sledgehammer to an old cast iron, either a grate or a cast iron manhole lid. You can break them. They shatter. And the problem with them is you don't quite know how strong that cast iron is, because we don't have the same sort of, or we didn't in those days have the same sort of codes for uniformity of chemical composition as we do today. And when you see how it was cast, you will actually see why there are certain problems in it. This was brought to the fore in the early 2000s, and you can see there's an article here in the NCE of the collapse of a roof of quite an established building in Bayswater in Hyde Park Gardens, because of the shearing of two shallow roof arches or beams, and it put a bit of a shiver through the engineering community, and for those who had buildings with cast iron in them, how much can they rely on these structures? So let's have a look at how it's built and why we get this lack of uniformity. So cast iron, use a wet sand pit, create the shape you want, then pour the molten cast iron into it, which is fine. That's great. Fairly common thing to do. But of course, while it's in its molten state, gas bubbles are starting to rise to the top. They bring the impurities with them. And guess where they all end up? Or most of them end up in the flange, which when you turn it over is that point of the element that's going to take most of the load. So you get irregularities in it. And that's the problem. We don't quite know what quality you've got. So obviously Brighton Royal Pavilion realised that they'd got quite a lot of cast iron in the place, and where they'd got big supporting structures like the Adelaide balcony, they had a major problem. So they called in John Holden Associates, who'd been involved in the Bayswater collapses, and said, come and have a look at ours. And they tested the steel or the cast iron in the Adelaide balcony and realised it was actually of fairly poor quality. Did a structural analysis on it and realised, in fact, there was a factor of safety of less than 1 on that balcony. And that's when we were called in. So the first thing they did was put some props at midpoint in. So you've got a series of jack arches here with cast iron T-beams running from that right-hand wall where the King's apartments are out to the line of the stone columns. About a 5.4 metre span. So we were asked our opinion of what could and couldn't be done. As I say, we tend to use all sorts of different types of materials, and Brighton and Hove Borough Council knew us very well from helping them with a number of buildings in the area. And we said, well, look, you could do nothing and just shut the cafe down, don't let anybody on it. I'm sure it'll be absolutely all right, which is fairly unacceptable. They need income coming in from the cafe, and from things like weddings, and they use it for governmental get-togethers with foreign dignitaries and things like that. You could actually install a set of secondary beams. So instead, take the props out, put something in just a little nicer than props, but pretty invasive and pretty unacceptable on a grade 1 gold star listed structure. But you could use carbon fibre. Now, for those of you who have never seen carbon fibre, that is a piece of carbon fibre plate, 100 mil wide, 1.4 mil thick, stiff as anything. Absolutely amazing stuff, and we use that for strengthening mostly RC, reinforced concrete slabs and beams, but you can use it with steel. So we thought, oh, that'd be quite a neat way, no weight or virtually no weight added. Very elegant solution. Big problem, which we hadn't considered until we had to look at this particular issue, is that cast iron is non-malleable, so it's stiff as anything. So it doesn't, not like steelwork. It doesn't deflect. It literally goes to where it needs to go, and if you overstate its strength, it actually shears and snaps. So the problem is you're not going to mobilize the tensile capacity of this material, because in fact it's going to shear rather than stretch it as it would if a steel beam bent. So in fact what you have to do then is cool the cast iron down, which would be possible to do with a sort of a refrigeration system within that area. We could cool it down. You then bond this to the underside of it, and when it expands, it puts that under tension. Except it doesn't, because the adhesive that you use needs to be roughly 10 degrees and above to cure. So of course, what happens is the beam then expands, the resin then cures, and of course you get no benefit. You might as well use duct tape. So that's not the answer, but there is an answer using carbon fibre, and that's to use a fabric. And instead of strengthening the cast iron beam, you actually make the brickwork span laterally rather than circumferentially. So it will spread the balcony loads down onto the beams, but if you make it act as a beam as well, spanning from the wall out to the columns, then in fact it will take load off the beam, and that's the secret of it. This I keep using this because it's easy to show, is a unilateral fabric. Well, not fabric, it's actually a plate, and it's pultruded, so all the strands, which are about 0.3 of a millimeter, are actually pulled through a die under tension, and you get a plate. We want unidirectional fabric again, because we're going to make that brickwork span from one end to the other. Things like boats, cars, aircraft are generally made from biodirectional carbon fiber because they get stresses in both directions. When you come to unidirectional sheeting, which is literally like a fabric, you still have to weave it together. Otherwise, all the tiny little strands of carbon fiber would just fall apart. You'd never be able to handle it. So it is loosely woven, as you can see there. And what we're going to do is we're going to bond that to the brickwork. Not quite as easy as it sounds. We had Colin Thompson Partners do the design. We do a lot of work with these guys on listed buildings. So they did a design, which in fact had come from I can't remember the name of the other engineers off the top of my head now, but it was an idea that had come from them, and it was to strengthen that brickwork, as you can see there. So then we had to set about it. Now, and for those of you who have worked on a listed building, protection is kind of everything, and this one was we'd not come across anything like it. Everything had to be fireproof wrapped in case it got knocked. The fact that there could be a fire, everything had to be in fireproof sheeting. They're paranoid about dust getting into all the antiquities, as you can imagine, in the King's apartments or anywhere else, and any type of damage that could occur, we had to protect from it. We then encased ourselves with with sheeting like that, and we had ourselves a rather nice working environment. So you can control the temperature in there. You can do all sorts of bits and pieces to control dust and the whole lot. Any sort of listed building you work on, I remember me saying you've got to record everything you do. So in this particular case, I can't remember off the top of my head, I think we had something like 14 beams. They all have to be numbered. The brick arches had to be numbered, and then everything you do to each one is recorded, again for posterity, so that everybody knows what the record of what's happened to the building is as time goes forward. You can probably see there some lines on the render soffit, and you can see us now using that good old Hilti wall chaser. And the beauty of this is we can vary the cut to within probably 0.5 millimeter of where we want it, so that we don't damage the brickwork underneath, but we are going through the render, and you get vacuum recovery, so you don't get just clouds of dust. So it's a great bit of kit, and it's very accurate. So one of the things that, again, the conservation officer will insist on is that you remove as little of the existing fabric as possible, no matter whether it's original fabric or not. So we had to literally mark out that 200mm strip, and that's the only bit of render they wanted us to take off. Now, what we actually found was that most of it fell off because it hadn't been bonded very well with the jack arches, the brickwork. What we also found when we took it off was, you see the cast iron beam there, but there's actually an infill of stonework. We think because the bricks didn't exactly size the span of the beams. So they've used limestone in there. It's not a problem, doesn't make any difference, but you just find things that you weren't expecting to. So we can actually see there, we've left a biscuit. That was part of the render that remained. We had to keep it there. And of course, you've then got to match with it, which makes things a little trickier. So there it is, all the brickwork, all the render removed that we're allowed to take off or fell off. So you've then got to clean all that brickwork, because you're going to need to bond your carbon fiber sheet to that brickwork. That's everything. because as you know, if you put a piece of tape on something to hold things together and it's slightly damp or there's dust on it, tape just falls off. Exactly the same with carbon fiber. If you don't get the bond to the substrate, you might as well have used duct tape. So that's the key to everything. So it's got to be cleaned. You don't sort of jet wash this sort of stuff, but it literally has to be vacuumed, wiped down, and then ready. And of course, to get the bond that you need between the carbon fiber and the brickwork, you have to test it. You've got to know what's going to happen, because let's say you've got something as stiff and as load bearing as carbon fiber, but the surface of that brickwork is friable. It'll just pull off. It'll never transmit the load. So you need to get a really good idea of what that bond strength is at the surface. And what you do is you take these 50mm diameter dollies, which are about 2,000 square millimeters, and you bond them to the brickwork, and then allow that adhesive to go off, and then pull them off normal to the surface and see what sort of bond strength you've got. Now, what you really want to see, ideally, is the adhesive pulling part of that brick surface off, or if you're doing it to concrete, part of the concrete, and then you know exactly what that bond strength is going to be. And what we're looking for is a figure of 1.25 newtons per millimeter squared as a bond strength. If you achieve that, then you're going to fully maximize the potential of the carbon fiber. Brickwork, not normal to put carbon fiber to, so we were interested in this. It passed with flying colours, and we were getting 3, 4, even 5 newtons per millimeter squared. And we do this in a random set of trials throughout to get a really good feeling of what that brickwork is going to be like. And before we started putting the carbon fiber on, we actually jacked some of the load out of the cast iron. Now, you can't do very much jacking because remember it's stiff and brittle. So we were only putting about 8 kilonewtons in to each of the jacks. But what that did was that just took some of the load out and lifted only by a couple of millimeters the center of the balcony. That meant that after we'd bonded the carbon fiber to it and we took the jacks out, it will immediately put some tension into the carbon fiber, which then is helping the cast iron. That actually is Annie. She is our conservation manager, so she looks after all the jobs that we do for listed buildings, and was there getting involved in everything we do. But Annie will, if you need design and access statements or any advice on listed building works, Annie is your girl. She will help you. But then we came down to the cutting it. So everything's prepared, everything's ready to go, and we now need to make these sheets exactly the right size. You can now get carbon fiber sheet in rolls of different widths. In those days, you could only came in 500mm wide rolls, and we needed 200. So in fact, they were cut. Each one was cut, but very easy. You're running along the lines of it. But a good pair of shears will actually cut through carbon fiber in any direction. As you can see, we've got a lovely sort of laboratory quality working environment. So we've got the brickwork exposed, as you saw. We've cleaned it, but we still prime it. And the reason for that is that any little sort of loose particles here or there get bonded back into the brickwork. And you'll see the next thing is a regulating coat. Now, you would think, yeah, brickwork looks pretty all right. We're going to wallpaper it with carbon fiber. It'll be absolutely fine. But actually, when you put a straight edge to that brickwork, you'll see there's 2 or 3 mil here between brick levels, a little bit of mortar pointing, sticking out. And actually, in relative terms, it's a bit higgledy-piggledy. Carbon fiber, unlike wallpaper, won't drop round little cracks and bond right to it, it will bridge those cracks. And as soon as you bridge anything, then you haven't got full bond, and you're not going to then mobilize the full 100% of the area of the carbon fiber. So everything has to be smoothed out. So we've got one of our guys here, John. He's worked for us for over 25 years now. He's a master plasterer and screeder, and I think he's the only guy I've ever seen who can handle what is a thixotropic epoxy adhesive or putty, and actually make it go the shape he wants it. And so every one of those had to be in a curve and smooth, so that when you then bond the carbon fiber to it, you get a full 100% intimate bond. The putty, of course, goes into all the little shapes of the brickwork, and you get a full bond on that. So that's what we call a regulating coat. And then we can start to apply the carbon fiber sheet. Now you will see here that, and in that list, we've got the first layup, which is 9 sheets. Now, I still don't know why, out of 21 total layers of carbon fiber we're going to put up, we didn't do 7, 7, and 7. But for some reason, it was 9, 9, and 3. I've absolutely got no idea why, and I don't know why I didn't ask the question at the time. But you put it up in a series of layers like that because, if you remember, the only layer that's in contact with the brickwork, which is the most important one, is that first layer. And so if you don't get that bonded correctly, you might as well not bother doing the rest of it. So you want to put them up in a number of layers. Remember, it's only 0.3 of a millimeter thick, this carbon fiber sheet. So there's not a lot of weight there, even with the adhesive on it. And you do it in a layer of 9. That allows that first layer to cure properly without tending to allow gravity to pull it off. And then you do the next, go down the line, do the next, and then come back and start doing second layup, and the same, and the third layup. And you can see here we use a roller. So the resin itself, we went for blue because we wanted to see exactly where it went. But in fact, normally it's a kind of a honey color. It's about the consistency of honey, and it rolls on, so it drip down your elbows all over the place, but will fully saturate the sheet. And that's what you want. You want the carbon fiber, the epoxy resin to go right the way through the sheet and bond all the individual strands together. So you use a roller, and then you use a rubber squeegee, and that will press the carbon fiber sheet up to the one above it, and make sure that you pull all the resin right the way through, ready for the next sheet, until you've got it finished. And there you are. So you now have, once it's cured, and that will literally, depending on the time of year, only take 1 or 2 days, and you've got yourself a fully strengthened balcony, which means you can take the jacks out. And then you've got to put the render back. For those of you who don't know or don't work on listed buildings, if you're going to match a material, you have to have it analyzed. So if it's a mortar that goes in between stonework or brickwork, take a sample, it goes down to the lime center or equivalent place. They analyze it and they come back with a mixed design, so that you know that you're going to put back like for like. So that's what we did here. Guess what? It was sand and cement. So that render that had been put on that, we don't know when, I think about 30 years ago, was actually sand and cement. It wouldn't have been that in the first place. It would have been lime render, but for some reason they'd managed to get sand and cement on it. And so we had to match that. We were, however, allowed to put in some SPR, and which is a sort of an additive that makes the sand cement more sticky, and slightly more pliable, so it bonds better and will last much longer. So there's a scratch coat going up, and there's the completed items. That's all done by hand. John was the master plasterer, you saw him earlier on, and you end up with basically something that you can't tell that carbon fibre has been used. So there you are. So you will now know if you go to Brighton Pavilion that in fact that Adelaide balcony is strengthened with carbon fibre sheet. That now has a factor of safety in excess of 2. So if you go to a wedding up there, and you can quite happily jump around and dance on that balcony. Fully completed, very happy client. Heritage works we do all over the country. And I'm going to take you to the Isle of Wight now. This is a beautiful monastery, basically. Benedictine monks built this at the turn of the century, last century. Came across from France with cases full of francs, or whatever they had at the time, and built. Who the architect was, I don't know. I've never found out. But superb artistry in brickwork. It's beautiful, and has been for most of its life so far, until they started getting cracking in the arches, and which is worrying in itself. But then they started getting masonry falling out. And they use that in daily prayer. They use that whole aisle in daily prayer. And it's used to get revenue in with members of the public paying tickets to come and have a look at it. And if you go down, it's well worth going down there. It's called Core Abbey, and it's Quarr on the Isle of Wight. Fantastic. 12 meters to the pinnacle there. And it's just superb. We had to come up with a method of stabilizing those and preventing masonry dropping out, so they continue to use it. We can't take the problem away of why this has been caused. We think it's foundation movement at the moment. There's ongoing investigation going into that, but it's literally to make it safe in the meantime, stop mortar dropping out. So we designed a series of plates, masonry reinforcement, pins, that sort of thing to go into those arches. Fascinating project. We couldn't fully scaffold it as we wanted to. We had to use towers because, again, we had to work at different times to the prayer times and allow people in and out. But we're working on 12-meter high towers, which it's not that efficient, but you work with what you've got. Now the cracks themselves went through most arches, some more severe than others, as you can see there, but even in the crypt. So these are much smaller arches under the floor. You can see the floor up there, the concrete floor of the aisle. And we found areas of brickwork that just could not be just mended and pinned and reinforced. We had to take that apart, rebuild it, incorporating plates and masonry reinforcement, again to try and help it spread the load as the building moved. And that's it. So to date, this was about 5 years ago, I think. We believe all is good, although again they've got some major foundation issues which are being looked into. But great project, really fascinating. We love unusual ones, and we love being able to having to scratch our heads and solve problems. And here's one. You'll have probably been to Bath as well. Many people. It's a fascinating city, a Roman city, and we were asked by or BANES, as they're called, Bath and North East Somerset Council, to help them with a problem they had with York Street. York Street is directly over an old Roman road or pavement and is right next to the Roman baths. So that might be familiar for those of you who've been there. On the right-hand photo, you can see the cathedral in the background. And where those ladies are walking is on York Street, and they are below a wall with balustrade columns on, or pilasters on it, if you hopped onto that wall and looked down in there, you'd be looking down into the Roman bath, that exhibition bath, the main one with the steam coming off it and the slightly sulphurous smell. That's where you are. So you're right above the old Roman pavement. Because what the Victorians did was raise the level of the roads in a lot of Bath to come up above the old Roman road and to provide equality in levels for various parts of it for the main shopping street. And so in fact, you can see York Street there going under the arch is actually elevated off the Roman road and is supported on composite beams spanning from the Roman baths on one side over to under that pavement is a new wall and a series of columns set in the middle. And the problem they've got, for those of you who've been there, these are sulphurous springs. So you've got obviously the acid in the air, you've got the moisture and the elevated temperature, absolutely perfect for corroding steel. This is what it looks like underneath. So we're looking up to York Street there, and you can see those grey spanning composite beams. So they sit on a wall on the right-hand side, that's under that pavement, central column, and then onto a support wall which divides the baths from this area of Roman pavement. Now the big issue is you're actually looking down onto the Roman pavement. Yes, it's got some sand on it to protect it, but basically that is the Roman pavement. So the archaeologists are paranoid that you will damage that. So you've got to try and negotiate with them how we're going to work on those beams without damaging that pavement. And really we needed it. We needed an elevating platform to go in there. And so we had to negotiate how we design the scaffolding platform to sit on without damaging on that Roman pavement. It's all part of the fun. Here's a drawing showing you in plan at the top those beams that we had to deal with supporting York Street. You can see though the curved walls of the dividing wall to the Roman baths made out of these are not load bearing, but made out of concrete blocks. Pretty horrible. And when you go to the baths and look on the inside, you will see recesses that look like stone that have been plastered onto the inside of those, where you can have your photo taken with a Roman centurion or whoever. But it's part of the exhibition. And one of the restrictions that we had was making no noise or disturbance, because you've got fee-paying customers coming into the Roman baths. So we had to be quiet, and we couldn't make any dust. So how are we going to swap out what is a significant size beam from under the road on top of Roman pavement in an environment like that? Well, I think we came to the fairly quick conclusion that you could not remove those beams. You had to enhance them in some way. And the reason there's a problem with them, as you'll see in a minute, is there's two steel beams side by side, butting each other, surrounded in concrete. Now, the surrounding in concrete, it was a great idea from the Victorians, but they didn't fill the void in between it. So when you get to the ends where they're supported, you've got them exposed to the atmosphere and all the moisture, temperature, acidity that goes with being close to hot springs, hence the corrosion. So they knew that the bearing ends of these beams were suspect. Closed York Street until something could be done about it. Called us in. We had to look at the practical aspects of how we are going to enhance those beams. This is what we had to work around. Old Roman ruins, walls made of bits of old abbey. But we persuaded the conservation officer and archaeologists that we knew what we were doing, and we could put up a proper working platform. And there you can see it there. You can also see that the Victorians used composite beams and concrete jack arches to support York Street. We found that, we investigated it, the concrete actual jack arches were fine. They weren't suffering in any way. So there's our working environment. So not only did we have all the Roman artifacts, we had cables, pipes, electricity, gas, drainage, pipes all running through there that we had to work around. So we decided we better have a look at this corrosion. So right on the middle of the span, we took off this very hard encasing Roman concrete to have a look at the Victorian steel. Pretty good, actually. Yes, you can see it's rusted on the outside, but literally only just on the outside. So it was purely the ends that were the problem. So here's the solution. And the reason we went for this was that we could manhandle sections of C-beam, whereas we couldn't pull in full length replacement I-beams or anything like that. And you can imagine the noise of busting out that composite old beam. So the idea was that we would clamp a new section either side, bolt it through, and that would do the full job of the beams should there be any failure. So that's what we came at. It was the only practical way of doing it. But as you can see, it meant drilling an awful lot of holes through the existing cast iron beam or composite beam. And each beam, because of the weight, because of the access restrictions of getting under York Street, you could only do it in a third of the length of these beams. So there was something like about 14 odd meters. That was the two of them. So about 7.5 meters long in total. And we cut that down into roughly a third. But each composite beam was a different length and slightly different dimensions. So we had to cater for all that as well. So we had templates made so that we could, for each individual beam, so that we could mark them and drill them in exactly the right place, and a duplicate set of templates went to the fabricator so that they could do cast iron, thinking of cast iron again, steel beams fully galvanized. Okay, so the holes had to be in the right place so that the whole sockets are galvanized as well to limit corrosion. So then we marked them out and off went the diamond drillers. Now these diamond drillers had never had this before, very experienced, but they are drilling through concrete, steel, void, steel, and then concrete on the other side. And they had to be millimeter accurate because our bolt fixings are going to have to go through and pull this together. Great set of guys, 1,500 holes in total we had to do in exactly the right place. And we took all the samples out from the coring, and as you can see there, yeah, that steel's still pretty good, with a tiny little bit of rusting on the outside. So in fact, yeah, in general, those beams are pretty good, just couldn't rely on the ends. What we did find was that when the Victorians encapsulated those beams, of course, they didn't care too much what the outside was. It didn't have to be specifically vertical. And so, in fact, the concrete itself was all over the place. We needed it even because we're going to have to sandwich our C sections right onto the beam and get them normal to the steel. So we put up guides and then rendered it. We had to monitor vibration and all the bits and pieces. And here's our guides, and they're actually rendering using 40 Newton high build repair concrete. Talking about the access, that was it. A manhole on York Street. So everything had to go in through there. There was no other easy access. Literally, there was no either come through the museum, which would have halted it all, over glass balustrades and all sorts of bits and pieces trying to get these in, or via the tradesman's entrance, which you couldn't even get a sheet of ply through. So this was the way of doing it. All sections went down, lifted into place with these nice little lightweight scissor lifts that we had down there, bolted through, and then remembering that we've got a void between the old Victorian steels, which we said should be grouted up, again to try and prevent ongoing corrosion. So in fact, we built in injection holes into the beams as we went, and then created a flow of grout through to grout up that annulus. Archaeologists paranoid about spilling any grout onto the Roman pavement, so polythene, kids paddling pools, buckets, you named it, we did it. And here we are with the grouting. And that's it, finished with all the dry packing between the beams and the tops of the columns and the jack arches. And if you go down there today, which you can, it's been turned into part of the museum. So you can see all Roman artifacts in there. I think schools go down doing little projects. And in fact, there's an archaeological pit where you can go and scratch around in the sand and uncover bits of obviously false Roman ruins, or ruin artifacts, but it's quite an exciting thing for the kids, but well worth doing. A great project, and literally having to think laterally of how are we going to do this. They didn't lose a single day of the museum. People coming in, obviously paying good money to keep the museum going. Right, so we're going to finish with something completely different. It's an arch. And it's quite an interesting arch. We're brought in by insurers. We do a lot of work for insurers, everything from subsidence to fire and damage and flood and all sorts of bits and pieces. They knew we dealt with arches and they had a problem. This is a culvert, and it's in a place up in the northwest of the country called Ramsbottom, and it flows from a stream in the garden under the road and through and on down a hill in another part of a culvert. And it's pretty old. It's stone, as you can see, and it's badly collapsed. That idiot you can see there in the photograph is actually the client, and he is staring up into a void to the right of him, which you could actually get a mini clubman estate up into. Now that is up under his house. So we wouldn't go in. We did all our investigation with a GoPro on a pole, and investigating and surveying what we needed to. Just the other side, you can see a plain sort of white curve. That is actually the reinforced concrete part of the culvert, which the local authority own and goes under the road. This bit is owned by that chap there. And what you don't know is that the back wall of his house, his 400-year-old 3-story mill building made of stone, there's a half-meter thick 3-story wall sitting right over his head. So the foundations sit on the crown of that culvert. So in the state it's in, how do we repair it? So the idea is, well, the insurance were going to decant the client, take down the back wall of the house, which would have meant shutting the road as well, because the corner of the house is right on the road, rebuilding the culvert, and then rebuilding the house. The bill for that was absolutely extraordinary. So they came to us and said, do you think you can figure another way of doing it? And we looked at it very carefully, and my colleague and I, Simon, and said, yeah, I think we can come up with a safe method of work. And so we put that scheme together. It went to a temporary works engineer, independent, for checking, and we got the go-ahead for the budget, which didn't please the client because he fancied having his house rebuilt. But that gives you an idea of the sort of void that was under that back flank wall, all being washed out through scour. So we came up with a safe system of work, and basically rapid set concrete bags on the eroded bed of the culvert, onto which you can then put maybe props and laggings on the top to spread the load, so that we put one every meter, one a day, and we could work our way in securing the soffit. There we see it. We also tied the front and the back of the house together because the back of the house is hanging in the air, and we need it. If there's any movement, we need as much tying as possible, so we tied it through. We also carried out dynamic monitoring, so that should there be any movement at any time, the alarm would go off and we could make sure the guys get out safely. But what we actually did was to ensure that that back wall didn't do a sudden drop, because that is sitting right over the crown of the culvert, but the culvert dog legs in under that part of the building. So we could take that beam from the road back to solid land and create a beam into which we bonded the side wall of the house to try and limit any big sort of failure. If one bit of the culvert goes, hopefully the whole wall won't go there because we've spanned it and we've tied it through. Here we are. We're under there. We're starting to rebuild, and the problem is it's an arch. It's taking load. You can't just place bricks in because there's no compression. You need to create compression into it. And you can see there on the left, to do that, you pop the stones up, you drive timber wedges in there, you mortar it, and then point it. And you can see we've also used bits of helibar to again bridge and tie things together. Scour had been the problem here with some of the huge floods that we'd had, washed away the abutments, and down came various parts of the wall. So we in fact put those back in high strength concrete to limit scour in the future. Very cramped indeed, as you can see, trying to work in there with that stonework. And that's it finished. So in fact, it was, I think we charged them, and this is probably 5 years ago, about £250,000 to do that. We couldn't divert the stream. We had to work with that. So it was semi-pumped to keep the volumes low. And then we worked in a very tight environment. So these are the practical things we absolutely love. Thinking out of the box, trying to get a solution for the client. So I think that's the end. I hope I haven't rabbited on too long. If we've got any questions, Matt, then very, very happy to try and answer those.
Super over there. Thanks, Dave. Yeah, I know we've got two in the chat now. I can just quickly read out one from Bill Keane. So thanks, Bill. Interested in better understanding the composite design of the jack arch brickwork and carbon fibre to span laterally regarding code compliance. What is necessary to undertake any testing of the composite member?
Ooh, I tell you what, that's a very good question, Bill. I'd certainly think for Brighton Royal Pavilion, I think this was all done theoretically. There's a fair amount has been done with testing of carbon fibre, but that's a very good point. I might go back to CTP and just ask them that question, actually. So that's a good one. I don't know the answer to that, but I will find out.
And did have another one here from Symmetry Engineers. It was, with the Adelaide balcony, how do you calculate how much load is taken by the carbon fibre versus the beam?
Again, that is a very good question. And isn't it funny? Out of all the sort of years I've been doing this lecture, I've never been asked those two questions before. I'm going to need to find out, but I would say that the carbon fibre will probably take roundabout, and again, I'll eat my words if this proves to be wrong, but at least 50% of the 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 weight and active load or live load of the balcony as it's used during each and every day. But I need to find that out. And these are great questions, I've got to say, absolutely brilliant, and ones that we've never had before. So I dare say that CTP did some form of calculation. We never asked them what that was to find out what sort of load, because you've got 21 layers of carbon fiber there. It will take a significant load. But if you leave your emails with Matt, I'll find out and I'll come back to you because I'm fascinated now.
Yeah, guys, if you just chase me on that, I can, once Dave kind of asks the question, we can get back to you on that. I've got two more just coming as well, Dave, so I'll quickly read these two out as well. One from Ben, which Ben asked, did you also backfill the outer extent of the arch that held up the house wall?
Very good. Yes, I forgot to mention that. Yes, we after the arch had been completed, we went up into what was his lounge actually, and we drilled holes through the floor, which was he'd got a rudimentary concrete floor in there, and we actually put in there nearly 20 cubic meters of foam concrete. So it was something a bit lighter. It was about 1,700 kgs per cubic meter, trying to keep it as light as possible. But yes, it was backfilled. Again, thanks for that. Great question.
I think Ben, you were actually from CTP, so you, not saying you, but someone might be able to answer that previous question from CTP.
Oh, right.
We'll save that for another time. Moving on to this next one from Jack. A few questions in one. He says, do you come across issues in the adhesive of the Helifix bar being significantly stronger than the surrounding mortar masonry? And are the grades of strength in the adhesives and mortars specified? Also, is there a risk of decreasing the breathability and trapping of moisture to lime mortar based construction if there are large areas of stitching?
Oh, again, fantastic question that, or questions. So let's go on the strength of the mortars. Yes, in large volumes, the Heli Bond mortar would be significantly too hard, but because it's going in 10 mil layers with the bar inside it, and it is designed to micro crack. So if you actually take a sample, and we've done this built in a in a die with the bars in it, you can actually take that and actually you can bend it like this. So we've been through this with local authorities and things like English. The English Trust, I'm thinking of the Landmark Trust, English Heritage, because when we do some of those historic structures, we have to prove to them that they're not going to make that any harder than the fairly soft lime mortar around it, and they're always satisfied that that will be fine expansion wise and flexural wise. So yes, it works very well, but you wouldn't put a sort of a large lump of that sort of material in there. Well, it wouldn't be any point. It'd be too expensive as well. But yeah, within the bed joints, it works an absolute treat. I think was the other question about different types of material, wasn't it? Yeah, we tend to match mortar. So if there's any void filling in walls and you get a lot of that, then we will always go for the weakest mixed design of lime mortars to match any sort of lime mortars that are there, so you don't create hard spots.
Brilliant, thanks, Dave. And just had another one coming from Jeff. Jeff's asked, for the culvert below the house, how did you ensure a safe working space for the operatives for the initial strengthening items or anything?
We analysed the entrance to the culvert and realised that actually that was fully supported. It was a completed arch. Therefore, you could work 1 metre inside that, pop up your prop, put your bag down, put the prop up, stick your laggings up, screw the load up, and then you could work 1 metre beyond that, remembering that you've got spanning of the steelwork above as well. So yeah, that was one of the considerations. How did we make that a safe space for the guys working forward? But it was 1 a day, so everything had to cure before we could go in and do another. Great question.
Brilliant. Thank you, Dave. No more in the chat at the moment, so I suppose we do last call out to anyone who's got any final questions before we close off here.
So it's still the same owners.
But if there are, can you just shut? Can you? Thanks, Mark. If you do have any queries that come to mind or a project that suddenly go, oh yeah, that's a bit familiar, please don't hesitate to give us a call. We love trying to help people solve problems, and if we can just come in at slightly left field and see if there's an innovative way of getting to where we need to get to. Usually saves time and money, and keeps everybody happy. So thank you so much for listening today. Sorry if it's run on a little bit. I hope that was interesting. I say don't hesitate to give us a call if there's anything we can help with or any queries you've got from this. Thank you very much. Have a good week.
Thank you.
Pleasure. Great pleasure.